Algebra 2, reviewing for semester 2 final. We're going to convert degrees to radians and radians to degrees. So we have to recall that a conversion ratio is 180 degrees is equal to pi for radians. So if we have 295 degrees and we want to convert to radians, we would multiply it by pi over 180. To simplify this, you just go 295 over 180, simplify it down, and recall you need to write it as an improper fraction. So this would end up being 59 pi over 36. 675 degrees, we would times it by pi over 180. Once again, to convert this, you would have to take 675 over 180, simplify it down, write it as an improper fraction, so this would end up being 15 pi over 4. If we have 2 pi over 3 and we want to convert this to degrees, now we would multiply by 180 over pi. Here our pi's ends up canceling, so we just have to take 2/3 of 180, which is 120 degrees. Pi over 4, convert to degrees, we'd have to multiply by 180 over pi. Your pi's end up canceling, so we just have to take 180 times a fourth, or divided by 4, to get 45 degrees. You could also convert these by looking at your unit circle, seeing that pi over 4 is equivalent to 45 degrees. Similarly, you'd have 2 pi over 3 is equivalent to 120 degrees on your unit circle. Next, we're going to find the exact length of a circle with a radius of 6 and a central angle of 5 pi over 6. So recall, our formula for the arc length is the angle measure over, it's either 360 or 2 pi, depending on our units, is equal to the arc length over the circumference. So here, we are dealing with radians, so we would do 5 pi over 6 over 2 pi is equal to the arc length over the circumference, which would be 2 pi times your radius is 6. Now, recall when you're dealing with radians and our 2 pi's are both in the denominator, if we were to times both sides by 2 pi, these 2 pi's cancel. So we now have an equation that looks like 5 pi over 6 is equal to the arc length over the radius of 6. And then to solve this for arc length, we would just have to times by 6. Here your 6's cancel, so we are left with 5 pi. I guess we don't have units on here, so 5 pi units would be the exact length of the arc length. If you did want to do to the nearest hundredth, it doesn't say to the nearest hundredth, but you'd just take 5 times pi, 15.71 units would be to the approximate answer. And we will also discuss with this one finding the exact value using your unit circle. So here's your unit circle. It's got the degree mark with the radians, okay, all listed out, and then it has along the edge, it has our cosine and our sine values for each of the angles. So if we want to find the sine of 240 degrees, we first have to find 240, which is right here. We go down and we see this is the cosine value and the sine value. Well, the sine value is negative square root of 3 over 2, so this exact value would be negative square root of 3 over 2. Tangent of 300, so first find 300, here's 300. We see our cosine value and our sine value, and we recall that tangent is equal to sine over cosine. So this would be sine of 300 over cosine of 300. Well, the sine value there is negative square root of 3 over 2. Your cosine value is a half. Whenever you divide by fractions, it's the same as multiplying by the reciprocal. Your 2's cancel, and you're just left with negative square root of 3 for the tangent of 300. Sine of 3 pi over 4, so you have to find where 3 pi over 4 is on your unit circle. It is right here. So 3 pi over 4, the cosine and the sine values. The sine value for 3 pi over 4 is square root of 2 over 2. And secant of 3 pi over 2, so you have to find 3 pi over 2. So taking a look at your circle, here's 3 pi over 2. Secant, well, secant is the reciprocal of cosine. Cosine is 0. So secant is the same as 1 over cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. 1 over 0 is undefined. So this is actually an undefined value.